Hello everyone, can you hear me? Can everyone hear me? Please reply. Can you hear me? Right. People are ready for lecture? It's 3 o'clock. We can start with the lecture. People are ready for lecture? 3 o'clock. Okay, so let us start our module, module number 5, which is state space variable. Now, what is a state space? What is a state space variable? Now, if we consider an LTI system, so let us consider an LTI system. So I consider an LTI system, and to be very precise, it will be with memory. So this is a with memory system, which we also called as a dynamic system. So we have a dynamic system or with the memory LTI system, and to find the behavior of a system, we use a method called state space variable. Now, why this is called as a state space variable? What do you mean by state? What is a space? What are state variables? So, we know that every LTI system, if I consider an LTI system, so every LTI system is having certain inputs, or let us consider first one input and one output. We have an input and we have an output. Okay. Input we name it as x of t, let's say, and output is y of t. Now I wanted to represent the system output in terms of input. So if it is a continuous time system, we use a differential equation. So this is for a continuous time system. We use a differential equation. And instead of that, if I use x of n and y of n, then I will use a difference equation. So there are two methods of representation of an LTI system, which is dynamic in nature. When I'm using continuous time, it will be differential equation, and when it is discrete time, it will be difference equation. I hope everyone is getting through. Everyone is getting this. Please reply on the chat on YouTube. People can't hear me. I'm not. You're not able to hear me. Is it so? Please reply. Okay, everyone is able to hear, right? If I'm not wrong. Whatever the problems are, you can post it on the YouTube chat. I'll be going through the YouTube chat in between, so that I'll know what is the status. Okay. The doubts also you can raise through YouTube chat itself. You can just put in the doubt, and I will also in between I will sort that doubt for you. Is it fine with everyone? Only five, six people are watching. Why so? Can we go ahead? Okay. So let us move ahead. Uh, Now, let us define what do you mean by a state. So, if let's say this is my LTI system, which we called as with memory, okay. So, a state of a system, a state of a system is the information. Now, it is the information provided. So, a state of a system which provides a information, okay, provides a information, okay, uh, at time t0, okay. And suppose I get all the state is a condition of a system or the information of a system at t0, okay. And then if I move on to t1, let's say I wanted to go from t0 to t1, let's say the next time instance, then we we know that what is the initial condition at t0, and we can easily predict what will happen at t1. So state is a information provided of a system for t greater than or equal to t0, I would say. That means all the information what I required for the of a system to be known is called as the state of a system. Now, If the input is provided for all times, then I can calculate the output of at all times when I know the state of a system. Okay, so that is called as a state of a system. Now, what is a uh, variable? So, if I know the state of a system, so let's say I know the state of a system. Okay, that is the information of a system, and the the variable which which uh, provides the information. Okay, the information is called as state, and the variable which provides the information is called as state variable. So we have something called as a state. So we would summarize like this: have if I have something called as a state, then state is the information. It's the information, whereas state variable state variable is the information variable. So whenever I called a state, it is the information of a system, and whenever I called it a state variable, it is the variables which provides the information. This is called as a state variable. Now, states are, as we see that states gives you information about what happens with respect to time. So state variables and states will be depending on time. So they all are the function of time. So I would say that both of them, that is a state and state variables, are function of time because they deal everything with respect to time. Now, when they are in the function of time, so it could be continuous time or discrete time. So whenever it is a continuous time, I will be using t, and whenever it is a discrete time, I'll be using n as a function. Okay. Now let us go ahead and see how to define a state space or a state vector. So the next topic that we are coming to is, let's say, a state vector. Now, basically, if you consider, let's say, there are n variables, there are n state variables, let's say, okay, and I call them as, because I said that they are function of time. So we can say that, let's say, the variable are named as q1 of t, q2 of t, and so on till qn of t. Let's say these are the variables that I have. Then I can create a matrix of those variables, which we call as a vector. So I would create a matrix which we called as q of t, which is collection of this individual variable state variables, that is q1 of t, q2 of 3, q3 of t, so on and so forth, qn of t. So this is an n cross 1 vector, okay, which we called as a state vector. So the state vector consists of collection of n dimensional or n such variables collected together to represent a vector. Okay, now we have done this in terms of continuous time. I can represent the same thing for discrete time. So for discrete time, this will be q of n instead of q of t. And the variables will be q1 of n, then q2 of n, and so on till qn of n. This is how we represent a discrete time state vector. So we have a continuous time state vector and we have a discrete time state vector. So moving ahead, if I'm saying that there are n vectors, n such variables, then we say that, let's say, q1 of t is one of the axis. Similarly, q2 of t is another axis, and so on and so forth. I have qn of t as the axis. That means there are total n axes. So such a space with n such axes is called as a state space. So when we have the states q1 of t, q2 of t, and qn of t as the axis of a space, then the total space is of that n dimensional, or we call this as n dimensional state space. So we have state, then state variables, then state vector, and state space. We know what is a state. State is a information provided of a system, that is called as a state. The variables which provide those information are called as state variables. Collection of such variables is called as a state vector, and axis of such vectors creates a space which we call as a state space. How many people have understood this concept? Please reply on the chat. Everyone, please reply fast so that we can move ahead. Only one student have understood, I think so. That is Devashish. Rest of them, please reply soon. Okay, good, Bishan. You also understood. Okay, so let us take it ahead and check how to use this concept in actual representation of a LTI system. So now we are using state space. Now this is a very important concept from exam point of view. We'll write it as it is an IMP question. So this is representation of LTI system using state space. We'll be using state space and will be representing a LTI system. Now first we will consider the first A part will be considering a CT-LTI system, that is a continuous time LTI system. So as we have discussed before, the CT will be expressed in terms of a differential equation. So let us consider an n-dimensional differential equation or an nth order differential equation. So I can write it as d raised to n y of t by d t raised to n plus d raised to n minus 1 y of t by dt raised to n minus 1 with a constant of, let's say, a1, and so on and so forth. I have total n such constant a of n y of t, which is equal to x of t. So let us say this is my differential equation wherein x of t is the input, y of t is the output, and the total system is described by this differential equation. Okay, so now what we are going to do is we will assume that y of t, or we will give the state as the out the first state I will consider as q1 of t is the output y of t, I say. Okay, so q1 of t is equal to y1 of t. This is, let's say, I am assuming the state of the system. So first state of the system, I have assumed that uh, the output y of t is assumed to be q1 of t, that is the first state. Then I assume that q2 of t is equal to, let's say, I consider it to be y prime of t. So where y prime of t is nothing but dy of t by dt. Okay. Then we go for q3 of t is equal to y double prime of t, or I called it as y2 of t. It is nothing but d square y of t by dt square, or we can call it as d by dt of y prime of t. Okay, or we can call it as d by dt of q2 of t. Okay, so these are one and the same. So similarly, we can extend this idea because we have n dimensional differential equation. I can extend this idea to q n of t will be equal to q n of t will be equal to y raised to n minus 1 times of t. As you can see over here, when I'm computing y2, sorry, q2, I'm having y1. When I'm computing q3, the derivative is y2. Therefore, when we compute yn, n minus 1 derivative has to be taken, right? So 1 less, 2, 1 less is 1, then 3, 1 less is 2, and n, 1 less will be n minus 1. This is how we got our state variables. Okay, now we wanted to find, this is about the state variables. Let us take the derivative of the state variables. So we are taking the derivatives of state variables. So we start with the q1 dot t. What will be q1 dot t? Now q1 dot t is actually d of q1t by dt. So that is equal to, if you see over here, q1t is y of t. Therefore, q, if I take derivative on both sides, it will be dq1t by dt, which is equal to dyt by dt. And dyt by dt is nothing but q2t. So I can call that as q2t. So the derivative of q1t, first derivative of q1t is equal to q2t. Similarly, if I take derivative of q2t, which is q dot t, which is nothing but dq2t by dt, will be equal to, what it will be equal to? q3t. Okay, because if you observe closely, q3t is nothing but derivative of q2t. Here we have written already. Okay, so that is q3t. Similarly, what will be the derivative of, that is q dot nt, will be equal to, now check over here, what will be derivative of qnt. So let us go back to the differential equation. Now in the differential equation, this is what the quantity I'm finding about. That is derivative of qnt. This is actually my q dot nt. Okay. So if I wanted to find what is q dot nt, I will take all of these terms, these complete terms, on the other side of the equal to sign. Enough. So that will give me q dot nt will be equal to minus a1, isn't it? I'll write first the derivative in terms of derivative. N minus 1 dy of t upon dt raised to n minus 1 minus a2 dn minus 2 y of t upon dt n minus 2 minus so on minus an. No, we are not taking, we are taking y of t also on the other side. Yeah. So an, we'll take an on the other side. So this becomes y of t. And then the last term that is left out is plus x of t. Here, just compare. So x of t plus, no, this will be plus. Rest everyone will be minus. Now what we do is we will put the variables. See here, y of t variable we have just put it as q1 of, right. Next will be q2 of t, and so on and so forth. This will be qn of t. Yes or no? So in the increasing order, I will write now. Therefore, q dot of nt will be equal to, let us write in the increasing order. So this is minus qn, sorry, an q1 of t, because y of t we have written q1 of t, minus an minus 1, isn't it? q2 of t minus, and so on and so forth, minus. Okay, last minus will be a1 q n of t plus x of t. Agreed, everyone? Everyone understood how I got this equation? I called this as equation 1, I called this as equation 2, and I called this as equation number 3. How many people understood what I said right now? Please reply. All three equations, everyone is clear with it? How we got as q1, q2, q3, or qn, and q1 dot, q2 dot, and qn dot. That is the derivatives of the state variables. Everyone got it? Okay. Last equation. See, the last equation, what I am determined to find is the is it's the, let us go back and see the yeah, rest of them are sleeping or what? AR Khan, where is he? Went off. Janavi, are you there? Or stop watching? Okay. Okay. So let us go to the last equation and clarify. See what we want is we have the derivative, right? So we have dn y of t by dt. Okay, raised to n plus 1 d n minus 1 y of t by dt raised to n minus 1 plus a2 d raised to n minus 2 y of t by dt n minus 2. Okay, plus so on and so forth. I'll go on doing, and this becomes a n, sorry, a n y of t. This is equal to x of t. Now let us replace each of them with the variables. Now let us replace them with the variables. So I'll use some other colors here. Now check over here. Y of t, we have put y of t as q1t, right? Similarly, here we will the next term where I will get what? Q2t, right? Here I will get, okay, yeah. So this part will be QNT, right? So it will be QNT, right? Yeah. So this will be QNT, and this will be QN minus 1T. How can we say this? See, y of t directly q1t, right? First derivative q2t. So n minus 2 derivative n plus, so n minus 1 t, and n minus 1 derivative will go to n t, right? Now what we are determined to find is, see, this is my q n t. So when I'm saying q n t, it is actually derivative n minus 1th time y of t by dt n minus 1, right? Now we wanted to find what will be derivative n times. So actually, if I take derivative of q and t, I am going to achieve this part, isn't it? So when I take derivative of this, it means this term. To take once the derivative, this will be n times then, isn't it? So that is how we are going to do. So I wanted to find what will be the derivative of this term. So when I take derivative of this term, I will say q dot of t at what level? Nth level will be equal to, now this all the terms. Can you see these terms? I will push all these terms on the other side of this. Then it will be, let us first write in the normal form. So it will be x of t minus, okay, a1 t n minus 1 y of t dt can be written as a1 q n of t, right here, minus a2 q n minus 1 of t minus so on and so forth, minus a n q1 of t. This will be my equation. Now that equation we just write in terms of increasing order of n, okay, for q. So we write it like this. We write first the highest order, which is minus an q1 of t minus a2, sorry, a n minus 1, a n minus 1 q2 of t minus, and so on and so forth, minus a n q1, sorry, I'm extremely sorry, this will be a1 q n of t. Okay, and last left out terminal is x of t plus x of t. Agreed? This will be my last equation. Now you understood the last equation? Is it fine? Please reply fast so that we can go ahead. Chalo, let's go ahead. Now, the next portion that we are going to find is okay. Now this is what we got the derivatives in terms of q1, q2, q3. Okay, and we got what is q1, q2, q3, and we have assumed that y1 of t, sorry, y of t, not y1 of t. I'm extremely sorry. We have y of t is equal to q1 of t. That is our first assumption, right? So this becomes our output equation. This becomes our state derivatives equations, and we have state equations. Now let us summarize them and write in terms of matrix. That will be the last part that we can achieve. So I'll write the equations again so that every equation will be in front of you. We are writing uh, q1 dot p, which is equal to q2 p, comma, we have q2 dot t, which is equal to q3 t, and so on and so forth. We have q of n t, q dot, sorry, q dot n t, which is equal to minus a1 an q1 t minus an minus 1 q2 t minus so on and so forth, minus an q sorry, a1 q n of t plus x of t. Okay, and this is what the equations are. So let us write. So at the LHS of the equation, we have q1 dot t, q2 dot t, so on and so forth, qn dot t. This is my equations on the LHS, which is an n cross 1 matrix, which is equal to what it will be equal to, which is equal to, now here see, q1 of t has only one variable to it, that is q2t. So I have to write some matrix over here, which I don't know what it is. We can see over here that each of the derivative depends on q1, q2, q3. So I'll write here as q1 of t, q2 of t, and so on and so forth, qn of t. Okay, plus we have here plus. Okay, and we something have our last left is x of t, right? Which is not depending on any q1, q2, q3, which is only having the last final value of q1 of t. Let us check here. Q1 dot t has only one variable q2, so it has only one variable q2. So q1 is not present, q2 is present, q3 is not there, q4 is not there. Similarly, qn is not there, right? For q2 dot t, we have only q3 present, q1 is absent, q1 is absent, q2 is absent, q4 is absent, and rest other elements are absent. And for the final one, let us see what happens to the final one. The final one is for the q1 dot qn dot t, we have function variable as minus an, that is with respect to q1. Then we have minus an minus 1 for q2, and so on and so forth. We go for minus an minus 1, or sorry, an. Here we go up till minus a1, which is n total variables. Okay, and that has multiplication with q1, q2, qn. Over here, similarly, I can write we have x of t only added to one equation, that is the last equation, right? So it should get added only to the last equation. Rest everywhere it must go to 0. Agreed? So this is how a state variable or state space matrix representation looks like. Now, what are those? Let us name them. So to name them, I call this matrix as q dot t matrix. I call this matrix as a matrix. I call this matrix as a q of t matrix. And I call this matrix as a b matrix, and I have this as x of t. Now, A is having n cross n elements, B is having n cross 1 element, Q is having n cross 1 element, and Q dot T is also having n cross 1 element. This is how the complete matrix will look like. So let us come and generalize the equation. So we can say that Q dot T is equal to A Q of T plus B x of t. This is what the state equation is. Everyone understood how we got this? Please reply. Okay. Well, moving on to the next equation, that is with respect to y of t. We know y of t is equal to q1t. So we can write this as y of t is equal to q1t. So we can write it as y1t is equal to 1 0 0 dot 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 all zeros multiplied by q1t, q2t, and so on and so forth, qnt. Okay, therefore I can write final equations as q dot t is equal to a q of t plus b x of t, and y of t is equal to c q of t. Okay, these are the two general equations of state space we will be requiring. So q of t will be equal to a times of q of t plus bx of b is equal to plus bx of t, and next is y of t is equal to c q of t. This is so this matrix is my C matrix. Okay, read both the equations. Everyone, can we go for a problem? What should I repeat, Devashish? Can you please mention what should I repeat? Output equation nahi samjha? Is it so? Okay, output equation. So here, what we are representing is now I wanted to ultimately get the output, right? So okay, my mistake. I'm extremely sorry. I wrote y1 of t. So let us now represent the output also in terms of q1, q2, q3. So we have written an equation as y of t is equal to q1 of t. This is what we have written already, right? So what I'm doing is, let us write this equation also in terms of the n variables. So we know that it only has one variable, that is q1t. q2t will be 0, q3t will be 0. Similarly, all q and t's will be equal to 0. And I will multiply this row with a column of q1t, q2t, and so on and so forth to q capital N of t. This is how the state matrix will look like. Agreed? You understood what I said? So then what I say is this part, this matrix, we called it as a C matrix. So I can write y of t as equal to C matrix multiplied by this Q of T matrix. So it is y of t is equal to C into Q of T. Can you see it is very similar to Q dot T. See here, the Q dot T here has one term which is A into Q of T. Similarly, we have in y of t C into Q of T. Read. This is how it all works. Understood? Got it? Okay. Let's move ahead. So now we write a general. Now in this terms, I will write this also. So we will get finally two equations. So let us come to that two equations. So we have the first equation as y dot t is equal to a q of t plus b x of t, and y of t is equal to c q of t plus, I just write one extension, dx of t. This is just an extension to bring everything on the similar node. Okay. To just make it similar to the previous equation, we have written this dx of t. But ahead, we will require these two equations only. Okay. So let us check one problem and see how these equations can be implemented. So let us go for a problem. So let us take a problem. The problem says we need to represent an LTI system which is given by d cube y of t by dt cube plus 6 d square y of t by dt square plus 11 d y of t by dt plus 10 y of t equal to 8 x of t. Everyone there with me? We are starting with the problem now. Yeah, I'm also there. There are three of you. Yash, you are there. Devashish is there, and I think so. Bishan is there, and myself is also watching. That's why it is showing four. Rest, I don't know where they are. They are sleeping. So what to do? What happened? Hmm. Okay. So काय करायचं? Good. Let's do it. So let us go with the problem. Now, looking at the problem, we know the capital N is equal to what? 3. Yes or no? Capital N is 3 in this case. So when capital N is equal to 3, let us, this is a three-dimensional problem. So let us first consider Q1t. So Q1t will be equal to what? Y of t. Then I will have Q2t, which will be equal to y dot t. Then I will have Q3t, which is equal to y double dot or second prime of t. So no, yeah, stop at Q3. Don't go beyond Q3 because we wanted to find the, because our we have the n dimensional. Yeah, that is three dimensional. So we want n variables. So we got the n variables. After getting the n states, we wanted to find the n derivative. So we will first find q1 dot t, sorry, q1 dot t, which is equal to q2t, then q2 dot t will be equal to q3t, okay, and then finally we want q3 dot t. So when I wanted q3 dot t, let us go and check over here our assumptions, whatever our assumptions are. This quantity, that is y of t, is assumed to be q1t state. This is our y dot t. So y dot t is, this is q2t. This term, that is y double dot, will be by double dot of t, will be what? q3t. Now this term will be what? Y triple dot of t, which is not q4 but q3 dot of t. Don't go for q4. We are at third order equation. So I will write it as q3 dot of t. So what will be q3 dot of t? Taking all of this term on the other side. Yes or no? And then writing in terms of q1, q2 and q3. So we write it in terms of q1, q2, q3, starting with the lowest one. So I'll write minus 10 q1t minus 11 q2t minus 6 q3t plus 8 x of t. Agreed, everyone? This is how we got the final states. Yes or no? So we got this as our three equations, which I called it as Roman 1. This equation, we called it as Roman 2. The third equation I write, which is the output y of t is equal to q1 of t. This is my third equation. Okay. Now with this three equation, let us form our state space model. So the state space model will be, looking at the equation, we will form the state space model. So our state space model will be, let us take all the three equations into consideration. That will help you. Okay, so let us bring all three equations in front of us. So these are my three equations and let us form the state space model of it. So right side we have q1 dot t, q2 dot t and q3 dot t. Okay, this is the right side of the equations. Is equal to, I want a matrix, which is 1 cross 1. Now we know that q1 dot t depends on q2, so there is no q1, there is only q2, there is no q3. Okay, q2 dot t depends on q3, so no q1, no q2, only q3. q3 dot t depends on q1 with a variable minus 10, q2 with a variable minus 11, q3 which is with variable minus 6, and we multiply it with q1 of t, q2 of t and q3 of t. Okay, plus, okay, I'm giving plus, this last element is pending. The last element is only with respect to q3 dot t, so I'll have 1 over here, rest everything will be, sorry, oh, I'm extremely sorry, this will be, only 3 elements are there. So we have 0 0 1, or you can write it as 8 because it is not 1, x of, so this is my A matrix, this is my B matrix, this is my q dot t matrix, and this is my Q of T. Okay, so that is how we have reached to Q dot of T, which is equal to A Q of T plus B x of T. That point we have reached using this differential equation. Now, using the third equation, this is the third equation, I'll write the output matrix. So, using the third equation, we get y of t equals to, we have only q1 dependency, so it will be 1 and 0 dot 0. And here I will have in terms of q1t, q2t, and q3t. This is what the three equations are. So, this is my C, and there's no D over here. Okay. How many people understood this problem? You guys understood the problem? Simple? Is it simple? Yeah, now let us consider another case wherein we have multiple inputs and multiple outputs. Now, here there was only one input x of t and one output y of t. Now, let's say I have multiple inputs and multiple outputs. So, there we will not derive the equations, but let us write uh, the generalized equation directly so that it will, it is same on the same lines I will write, but it will be for multiple inputs and multiple outputs. So let us consider there are multiple input and multiple output. Okay. So we have uh, up till now there was only one input, one output. Now there are multiple inputs and multiple outputs. So what is the case that we are considering is, the case that we consider is there are total m inputs. I'm considering there are m inputs and there are p outputs. Okay, so there are total m inputs and there are total p outputs. So let us consider m inputs, p outputs. So we have now q dot t is equal to a into q of t plus b. Now x becomes a vector. So x will be also a vector and b will also be a matrix. So and y of t will be equal to c q of t plus plus d x of t. Okay. Now q of t is the state variables. So this will be a matrix with n cross 1 elements. Okay. X of t is the input vector. So it will be a matrix of, now we have m inputs. So we have m cross 1 matrix. Y of t is an output matrix. So we have P. So it will be P cross 1 matrix. And then A. A is a state matrix. So it will be having a total elements of n cross n. B is a matrix which depends on input. That's why it will have total uh, n states and m rows. Okay, so it will be n cross m. C is dependent on C depends on the output equation. That's why it is P cross N. And D again depends on input, so it will be P cross M. P cross M because it is in the output equation. That's why it is P cross M. So this is how the multiple input, multiple output equations will be. Let us see one problem on it because it will be easier for us to understand using a problem. So now let us consider that we have a differential equation again whose representation is to be shown. The differential equation is given as d cube y of t by dt cube plus 3 d square y of t by dt square plus 4 dy of t by dt plus 4 y of t equal to x1t plus 3 x square x2t plus 4 x cube of t, sorry, x3 of t. So now we have three inputs, and this is the relation of input and output of a system. And the outputs that we get is y1t. Now we have multiple outputs. Y1t is equal to 4 dyt by dt plus 3 x1 of t, and y2t is equal to d square y of t by dt square plus 4 x2t plus x3t. Okay, so here we have y2t depends on x2 and x3, whereas y1t depends on x1 alone, and the behavior of the system is given by the differential equation. Okay, now what is the order of the equation? The order of the equation is 3, so we have n is equal to 3 again. That is what the order of the equation is. N is equal to 3. So we will have q1 of t, which will be equal to y of t. Then we have q2 of t, which is equal to y dot of t. Then we have q3 of t, which is again y double dot of t. Okay. Then we find the derivatives, which is q1 dot of t, which will be equal to q2t. Then we have q2 dot of t, which is equal to q3t. Finally, when I wanted to find q3 dot of t, I'll go to the differential equation and move all these terms. Oh, I'm sorry. I'll move all these terms on the other side of the equation, and I'll write in terms of q1, q2, q3. So first comes minus 4 q1t minus 4 q2t minus 3 q3t plus x1t plus 3x2t plus 4x3t. Okay, then yeah, now the output equation. For the output equation you have y1 and y2. Okay, so let us write in y1 and y2 in terms of q1 and q2. So y1 of t will be equal to, now see, y1 of t is 4 times of dy t by dt. Dy t by dt is q2t. So we will write again here Y of t is my q1t, y dot of t will be q2t, y double dot of t will be equal to q3t, and this term is q3 dot t. Okay, so now here when I go y dy t by dt will be equal to q2t and x of t as it is. This is y double dot of t, which will be q3t, and x1 and x2 will be as it is. So let us consider that and write the equations. So we have y1 of t will be equal to 4 q2t plus 3 x1t, and y2t will be equal to q3t plus 4 x2t plus x3t. Yeah. Now combining all the equations together and writing it in the matrix form, that is the final form. So I'll write here q1 dot t, q2 dot t, and q3 dot t equal to a will be, now your q1 dot t has only q2, so I'll write 0 1 0. q2 dot t has only q3, so 0 0 1, and q3 has minus 4 minus 4 minus 3, will be with respect to q1, q2, and q3, plus now n cross m. So we don't have anything for the first row, anything for the second row, but with third row we do have. First is 1, 3, and 4. This is multiplied by x1t, x2t, and x3t. The last final we have 1, 3, 4. That is what we have written about. So this is my q dot t, this is A, this is B. Let us go for C. So y1, now we have two outputs. So we have y1t, y2t. Y1t is having 4q2. So q1 will be 0 and q3 will be 0. Y2 is having q3 and no q1, no q2 with 1 as a variable, plus input over here is here we don't have we have x1, we don't have x2, we don't have x3. Then we have over here x2, so no x1, x2 is 4, x3 is 1, x1t, x2t, and x3t. This is how the equations will look like. Everyone understood? So this is how multiple input, multiple output representation works. Now let us go to the next topic, that is a solution of state space equations using Laplace transform. So now this was from time to time only. Just we have represented the system, but we have not found the solution of the system. Now let us go to the solution of state space using frequency domain analysis we are doing. So using I'll be using Laplace transform because we are doing uh, simple CT systems, or Laplace transform will do. Now we know that our equations are given as q dot t is equal to a q of t plus b x of t, and y of t is equal to c q of t plus dx of t. This is what my two equations are. When I apply Laplace transform, q dot t is actually dqt by dt. It is like that, right? Everything is a vector. So I'll take derivative of each of them, right? So that is a derivative of the vector. And Laplace transform of a derivative is given as s times of q of s minus the initial condition. Now it is a single order derivative, so you get minus q of 0 is equal to a times of q of s plus b times of x of s. Similarly, second equation will be y of s equals to c q of s plus dx of s. What the second equation is. Now taking q of s on one side, we get s q of s minus a q of s equals to b x of s plus q of 0. Okay, so then taking q of s common, and we get s into I minus a equals to b x of s plus q 0, right? Yeah. Now let us find what is q of s from this. Q of s will be equal to, this will go down, that means it is s I minus a the whole inverse bx of s plus q0. Oh, sorry, this will be in the brackets because it will be whole. This will be bracket. Yeah. Now this quantity, this term, this s I minus a the whole inverse is called as phi of s. Okay, that's called as a phi of s, which has a name, which we called as a transition matrix. Called phi of s as what? The transition matrix. Okay. Now, rearranging the equation, I'll not prove the whole thing, but you rearrange the equations appropriately in terms of y and q. Rearrange, you get h of s equals to c phi of s into b plus d. So now, if anybody gives me b, c, d, and phi, I can calculate and give them h of s, that is the transfer function, using state space model. This is what the basic fundamental of a state space model is all about. I hope everyone understood what I have done just now. When you remove q of s, And as you pull it out, remained as all 1 1 1 1 1 1. So that 1 1 is nothing but your I, that is identity matrix. So this is what my transfer function is all about. Okay. So let us finish with the state vector, states transition matrix as well, and then we will take one problem for uh, this, and it will finish up the continuous time state space. So state transition matrix or state transition matrix is given as phi of t, which is equal to e raised to a t. Okay, that is what it is. Now, how to solve it? We will use only one method, which will be called as a Laplace transform method. We'll be using for calculating this a of t. Rest of the methods you please don't even look into. The Laplace transform method says that phi of t is equal to e raised to a t, which is equal to Laplace transform of Laplace inverse of s I minus a whole inverse. This is how we are going to solve characteristic root equations or characteristics equation. Understood, everyone? Is it fine? Is it going good? Let us take a example. Uh, one example which caters to three problems or two problems, that is every time asked in your paper. So that two problems we will cater to directly in one problem itself, and that will finish up with the continuous time system. So let us take up a problem. So the problem states as q1 dot t and q2 dot t. This is my matrix equals to, we have 0 1 minus 2 3 minus 2 minus 3. We have q1t and q2t plus 0 and 1 x of t. And here we have y of t, which is equal to 1 and 0, q1t and q2t. And they have asked us to find the characteristic equation and eigenvalues of the system. So that we are not going to do. It's okay. We'll directly find the transfer function and the states transition matrix. These two problems are very frequently asked. So they wanted us to find h of s and e raised to at, or we called it as phi of t. So for we need to give this two quantities to them, and this is always asked in the paper. So let us start the solution. And now we know that the transfer function h of s is given as C, we have just proved it. So C phi of S, sorry, C phi of S B plus D. Now, where is A, where is B, where is C, where is D? So we know that the general form, just we collect the general form. The general form states that q dot t is equal to A q t plus B x of t, and y of t is equal to C q t plus D x of t. So here, this matrix, this is my A matrix, this is my B matrix, this is my C matrix, and of course D is equal to 0. So because D is equal to 0, this term is gone. So this will turn to 0. So D is equal to 0. Okay. Now we need to find what is phi of S. What is phi of S? Now phi of S is what we have just found. Phi of S is Laplace, sorry, not Laplace. Phi of S is S into I minus A, the whole inverse, right? Now, this is my S. Okay. Identity matrix will be, because it is 2 cross 2, so I will have an identity matrix of 1001 minus the A matrix. A matrix is 0, 1, minus 2, minus 3. That will give me, now this will multiplied S minus 0. So the first term will be S, S. Then S into 0 is 0, minus 1 will be minus 1. Okay. 0, S into 0 is 0, minus of minus plus 2. S into 1 is S minus of minus plus 3. So this will be S plus 3. And then this is my phi S. Okay. It's not inverse. This is just phi S. Okay. No, not phi S. This is only S minus Si minus A. That is what we have calculated here. This is just Si minus A. We have not yet done the inverse. How to calculate the inverse? We will use the standard technique to calculate the inverse, which is a joint method. So we need to calculate phi of S, which is inverse of this, which is Si minus A, the inverse, is equal to 1 over a joint of Si minus A. Okay, sorry, I'm extremely sorry. 1 over determinant of Si minus A into a joint of Si minus A. I hope everyone know how to calculate this. When you calculate this terms, you get phi of S as, I'm not going to solve it. You get phi of S as S plus 3 divided by S square plus 3S 3S plus 2. Here we got 1 upon S square plus 3S plus 2. Here we have minus 2 upon S square plus 3S plus 2. And here we have S upon S square plus 3S plus 2. This is what the equation will finally turn around. Okay. Therefore, our final h of s, which is just now the multiplication of C matrix, phi of S matrix, and B matrix, will be equal to, now how will I write? C is 1 0. This is my phi of S, and then B is again 0 1. Okay, which is plus 0 because D is 0. Therefore, H of S will be 1 upon S square plus 3S plus 2. So it is, let me spare it now, will be S square plus 3S plus 2. First part everyone got of the output. Please reply. First part you got it. Let us go for the second. Then only we'll go for the second part, that is finding the state transition matrix. Okay, so let us go for the next last part of the problem. That is, we need to find phi of t, which is e raised to a t, which is nothing but Laplace inverse of uh, phi of s, we'll say. Okay, so that is equal to Laplace inverse of, we got phi of s, so we're just writing phi of s. Phi of s that we got is s plus 3 divided by s square plus 3s plus 2, 1 upon s square plus 3s plus 2. Here we have minus 2 upon s square plus 3s plus 2. Here we got s upon s square, sorry, s square plus 3s plus 2. Now taking Laplace inverse of this term, we cannot take direct the Laplace inverse of this. So you'll take individually the Laplace inverse of this term, then Laplace inverse of this term, Laplace inverse of this term, and then finally Laplace inverse of this term. While taking Laplace inverse of this term, you cannot directly take it. You have to apply partial fraction expansion, get the two terms, and then solve the equation. The final answer, I will write the final answer over here after Laplace transform. Final answer is, the first answer is 2 e raised to minus t minus e raised to minus 2t. Over here it will be e raised to minus t minus e raised to minus 2t. Over here it is minus 2 e raised to minus t plus 2 e raised to minus 2t. And here we have minus e raised to minus t plus 2 e raised to minus 2t. This is what the state transition matrix is all about. So these are the basic questions that they ask in your examination. You guys understood what I said, what I have done for the second part? Just need to take the Laplace inverse of what matrix we found, element wise. But when you find it for element wise, also you have to apply partial fraction in between, and then you get the final answer. So I hope you understood what I said. Yeah. So that's all from state space. I think so is necessary. Rest of the problems I will solve and send as a scanned notes on WhatsApp. Okay. Thank you. Thank you for watching. Bye bye.